Does anybody have bingoes for me?
Do I get $300 from that?
All right. So today we're going to talk about going backwards with our theorems. Okay. If we have a quadrilateral with opposite sides congruent, then we can say it's a parallelogram. Let's use a different color. Okay. So I see this parallelogram. Excuse me. I see this quadrilateral. I see that opposite sides are marked congruent. I know it's a parallelogram, and all of the other properties are going to be true also. Yes. It's right there. You left it here. And I put it there to save for you. Okay. If we have a quadrilateral and opposite angles are congruent, then we know it's a parallelogram, and all of the other properties will also be true. Now, the one that I really like this one. Okay. If we take one set of opposite sides in a quadrilateral, if they are both parallel and congruent, then we know it's a parallelogram. Okay. So I don't have to know anything about the other pair of opposite sides. If I take just one pair and they're both congruent and parallel, then everything else will fall into place with the properties of a parallelogram. It is amazing how much those have been a distraction in the past 24 hours. I don't know how they got there. All right, go to the next page. I think that means you have to turn the page. Okay. If you know nothing about a quadrilateral, but you know that the diagonals are bisecting each other, then you know it's a parallelogram. Stop the recording. Okay. Really, we have a converse for every theorem from last chapter, last section. Okay. With the addition of this one, where we can take one set and if they're congruent and parallel. Okay, so we have five ways to take a quadrilateral and say, oh, hey, it is a parallelogram. Okay. Okay, so I want you to look at numbers 1, 2, and 3, and I want you to just talk with your elbow partner. Are these parallelograms, and how do you know? Ready, set, go.
Yeah. One is not a parallelogram. One is not. And then 3 is they're all you. Two, yes. First one's no, yes. Yes, yes. Wait, what? Yes, yes, no. Oh.
Okay, is number 1 a parallelogram? Yes. We have one pair of opposite sides that are both congruent and parallel, because A equals A, people.
Oh.
Okay. Is number 2 a parallelogram? Yes. How do we know? Opposite angles are congruent. Is number 3 a parallelogram?
Yeah.
Yes. Why?
The diagonals converge.
The diagonals bisect each other. Okay. So what I'd like you to do, I would like you at your, well, with your partner, I would like you to find X and Y in numbers 4 and 6 to make those parallelograms.
It's not that deep. It's really not that deep. If it's not that deep, why are you saying? Yeah, I agree.
Wait, what?
Oh, no.
Miss Woman, can you sign this green thing?
I can. She just took
Can
it?
we turn it in when we go to the high school?
Have you, so you'll just have to get it this afternoon.
Yeah, wait, yeah, she has to sign this, sign the Spanish.
Yep, you turn it in on Monday at the high school when you go.
Like, keep all her passes.
It is 11:01.
No, like the thing on Monday.
Is there no school on Monday?
No, we have
Yeah.
on Monday.
It says 7 PM on your green sheet, it says,
We were here on Monday.
and Tuesday.
We have
Oh,
one.
yeah, because my parents were talking about that, because it has practice during the thing,
We would?
so like, in the high school.
Huh?
Oh,
It does the same time.
I saw her
Wait, is
brother.
it, wait, what's it called? It's not, don't give on Monday.
Monday is here, Tuesdays at the high school, Alexa.
No, but like, for the meeting. Oh. we have the high school?
Oh,
Oh.
I was like, this is not computing.
Maybe there's one left.
Thank you, Alexa. I get it now.
Did he was like, can we go home, Mom? And then she was like, ask your sister.
All right. If number 4 wants to be a parallelogram, Nora, what is X?
Oh, they're not equal.
You're right. 40.
Oh,
it is.
X equals 40? Brayden, how do we get X equals 40?
Add the x's, and then you subtract 20 from 40, and then you,
Oh my God.
subtract 20 from 180, that's 160.
What? So you're saying add these two and they equal 180? That's what I was going for. So X is 40. Okay. We need, if these are going to be parallel, we need these to be supplementary. Now, if we want a parallelogram, we also need consecutive angles or opposite angles to be congruent. So what is Y? Y equals 25. Because 4Y equals 80. I mean, not 80, 100. So you could do one of two things. You could say 4y plus 80 equals 180, or you could say that these two are equal, right? Okay. All right, how about down here in number 6? Ben, what did you get for x? Okay, and if we want x equals 8, Sam, how do we set up an equation?
Oh, then x plus 7 equals 12x minus
9. Maybe? Is that a 9?
yeah.
All right, Harvey, what's y?
I didn't get that.
But you can look at there's no algebra involved. 106. Awesome. Okay, so now this is the fun part. Okay, you can do this all day because you've already shown me that you can do it. The fun part is when we're in the coordinate plane. So what I'd like you to do is open up to page 7 of your packet. Yep. What else? Distance formula and or?
Dude, what's up?
Okay, well, we'll talk about it then. Okay, so there are 3 ways in the coordinate plane we can figure out if we have a parallelogram. Okay, the angles, but we're not going to worry about, and in a coordinate plane, the bisecting diagonals, we're not going to worry about that. Okay, if we want to prove we have a parallelogram in the coordinate plane, we have 3 different ways we can do it. Way number 1, we can show that we have both pairs of opposite sides congruent. Okay, so that would mean I need to show that in this picture, AB equals DC and AD equals BC. Now, if we're going to show segments congruent in the coordinate plane, what are we going to get to use? Clark?
If we can't do something on a coordinate plane, we have to see if they're parallel.
No, we are talking right now about, you already said it, you said distance formula.
Yeah.
Okay, if we have opposite sides congruent, we are going to need to prove that the distance from A to B is the same as the distance from D to C. The distance from A to D is the same as the distance from B to C. Then we could say, okay, we have parallelogram because both sets of opposite sides are the same. Okay. Now, we could say, hey, both pairs of opposite sides are parallel. So we could show AB is parallel to DC, and we could show that AD is parallel to BC. How do we know segments are parallel? They would have the same slope. You know what I like to find? Slope. Slope's fairly easy to find, right? No?
I completely forgot the scope.
It is. Y minus Y over X minus X.
I remember that.
I remember
Scale all
that
time. X
Why'd you make that?
squared.
That makes, there's something else
I
that,
remember. Then the quadratic form.
there's something that I didn't mention.
It's like B.
Yeah,
minus
y equals mx.
squared. Yeah, I don't like that one.
X equals negative B plus or minus
What
the
does
square
B
root
stand
of B
for?
squared minus 4AC all over 2A.
What does B stand for?
What?
We're not working with quadratics. We don't need it.
It's like that, right?
M is slope.
What's B?
Y equals mx.
Y intercept.
So if we're talking Y equals MX plus B, it's the Y intercept. Okay, moving on. We can also show that one pair of opposite sides is both congruent and parallel, which means we can pick one set of sides and show like, hey, AB and DC are equal and AB and DC are parallel, which means we would need to just take one pair of sides and use both the distance formula and slope. Okay, no matter what you are making for calculations, you are either doing the distance formula 4 times, you are either doing the slope formula 4 times, or you're doing 2 distance formulas and 2 slopes. All right. So
If you get 1 to 5 homes,
that is a choice. Here are our 3 problems. We are going to go in order with the methods for these 3 practice problems. Are you ready? Okay, so in this first one, I'll just name it number 1. We are going to determine whether the quadrilateral is a parallelogram by using the distance formula. So we need to find AB. We'll do that one first. Okay, so when we put in our coordinates, we want to say x minus x squared. And then we want to say y minus y squared. Okay, so we have 8 squared plus negative 2 squared. So we have 64 plus 4, so the square root of 68. Okay. If we want to compare the opposite side, what distance should we find now? Yeah, okay, let's find CD. So when we find the CD distance, we need to take x minus x squared and y minus y squared. Do we once again get 64 plus 4? Alexa, what's 1 minus 9? Okay, so we have negative 8 squared, so that's 64, right? What's negative 6 minus negative 8? 2. 2 squared is 4. Hey. Well, that's good. That's a good start, right? So now let's move on and try our other set of sides. What should we try first? BC? Sounds good. So if I'm going to find the distance between B and C, we're going to take, did you say 9 minus 1 squared and negative 8 minus 2 squared? All right, so we have 64 plus 100. So we have the square root of 164. Sweet. All right, what's the last side we need to find the distance? 80. Okay, so AD, we're gonna take 1 minus -7 squared. And we're gonna take -6 minus 4 squared. Do we get 64 plus 100 again? Yeah. Okay. Yep. So since AB equals CD and BC equals AD, then ABCD is a parallelogram. So this is parallelogram. Run out of results. Either write this or opposite sides congruent. Okay. So I can know that you understand what you just did. Okay. Sometimes it's not always about showing me the answer, but showing me that you understand the process too. Okay. Showing me that you understand what you're doing. Okay. So in number 2, we need to use the slope formula. Now, remember, slope formula, y minus y over x minus x. Please make sure you do that. So what I'm going to have you do, just like we did up there, we're going to use the slope formula. Instead, I want you to find me with your elbow partner the slopes of wx, yz, wy. Wait, hold on. No, xy and wz. Find me those slopes. -2/8, 2/-8, they both reduce to -1/4. It doesn't matter where the negative is, okay? Means the same thing. All right, WX, what are we getting for that slope? Huh? -1/4? Did you get -1/4 for YZ?
Yes.
Okay, that's good, right? Okay, so we have one set of sides parallel. Okay, what about for XY? For XY?
No, why is it?
So what about XY?
XY equals -7/4.
Okay. WZ?
No, isn't just -1?
-1? Well,
It's 8 because the 2 minuses.
Yeah.
Yep. Okay, so man, we thought we had it good, right?
So y is on top.
Oh, for slope. Okay, so WXYZ is not a parallelogram. Because our opposite sides.
If we ever do a worksheet like this, does it matter which?
So I'll explain, like what I want you to do in the homework, but you're gonna get to have some choice. Now, I have a question. What would it mean? Okay, so first of all, if I have one set parallel, and we'll talk about this more next week, but if I have one set of sides parallel and two not, what kind of figure is it? Like, what do we have right here?
A rhombus?
Trapezoid.
A trapezoid. A trapezoid. One set of sides parallel, the other two aren't. Right? Okay. Now, what if these slopes would have been 4? What would that mean? Opposite reciprocal slopes, what does that mean? Perpendicular, we would have right angles, we'd have some sort of rectangle. Okay, more on that next week. All right, so now in number 3, we're going to talk about taking JKLM and using the distance formula and slope on just one pair of opposite sides. Do you care what opposite sides we pick?
Yes, but no.
How about JK and LM? Okay, so let's find the distance of JK. So we're gonna need to take what? -5 minus -9 squared, and then we're gonna need to take 1 minus -2 squared. Does that sound good? So what do we have 16 plus 9? No way. No way. What does that mean? What's our distance? Close. Square root of 25, which is 5. All right, LM. We're gonna need to take -3 minus 1 squared and -7 minus -4 squared. Do we once again get 16 plus 9? Love it. Yep. So this is a good start. We have one pair of opposite sides that are congruent. Thank you for using the right word. Okay, now let's see if they're also parallel. So we're still working with JK. We are still working with LM, but we're gonna work on their slope now. So for JK, we would need to take 1 minus -2 over -5 minus -9, which would get us -3/4, right? Nope, not negative. Definitely positive. I got excited. You playing tic-tac-toe with yourself? I bet you'll win.
I beat myself twice.
Wow.
Wow.
All right. Now for LM, we need to take -7 minus -4 over -3 minus 1. What do we get? -3 over -4, which is the same thing as 3/4. Okay. So we know that JKLM is a parallelogram because we have opposite sides, parallel and congruent.